In this video, we're gonna know more about arithmetic sequence and series. Arithmetic sequence is a pattern with the same common difference between each two consecutive terms. In the first example, as you can see, 2 plus 2 equals 4, plus 2, 6, plus 2, 8. So this is an arithmetic sequence with a common difference 2. You can find the common difference d by subtracting any term minus the previous term. So 4 minus 2 equals 2. In the second example, negative 1 become negative 4. So minus 3 each time, minus 3, 7, minus 3, negative 10. So also this is an arithmetic sequence with a common difference negative 10 minus negative 7. Negative by negative positive, so it's gonna be negative 3. Let's check the next example. 3 becomes 6, so plus 3, 6 become 10, plus 4, 10 become 15, plus 5. So this is not an arithmetic sequence because the common difference is not the same each time. You may find the general rule in the data booklet, as you can see. The nth term of an arithmetic sequence, un is the value of the nth term, n is the number of terms, u1 is the first term, and d is the common difference. So for example, if I said u10 equals 15, 15 is the value of the u10, and the 10 the number of terms. So this is the 10th term. The next part, it's very important in any arithmetic sequence to refer to any term with the first term. So the first term is u1, the second term we just added the common difference d. So u2 equals u1 plus d. From u2 to u3 you just added the one more common difference. So u3 is u1 plus 2d. By the same way, u4 u1 plus 3d. If you follow the same pattern, so any term equal u1 plus n minus 1d. So u10 equals u1 plus 9d. This part is very important to answer most of the questions quickly, and it's an exam hint. In example 1, you have arithmetic sequence with the first term 7, so u1 equals 7, common difference d equals 8, and you want to find u10. The data booklet, as we mentioned, contains the rules, so you don't have to memorize it, although if you remember it, you're gonna save some time. So u10 equals u1 7 plus n minus 1 d by 8. By u10, calculate 10 minus 1 equals 9, 9 by 8, 72 plus 7, 79. In this example, you have the third term of arithmetic sequence 10, and the 15th term is 46. So u3 equals 10, and u15 equals 46. And you want to find the first term u1 and d. The easiest way to answer this question and fastest way to find the common difference first. So the common difference in this case is going to be the value of any term minus the value of previous term over number of the first term minus number of previous term. Okay, let's apply this to our problem. So d equal the value of any term, always start with the greater term, so 46, minus the value of a previous term, 10, over the number of this term, the one you started with, is term number 15, minus the previous term number, which is 3, equal, simplify 46 minus 10, 36, over 12 equals 3. So D equals 3. Now you have to find U1 first. U3, as we said before, is U1 plus 2D. U3 equals 10. U1, you want to find it, plus D3, so 2 by 3, 6. U1 equals 4. In this example, you have an arithmetic sequence and you want to find how many terms of this arithmetic sequence. The number of terms of arithmetic sequence is the same number of the last term number. So you want to find 100 is which term? Do you remember the rule? Un equals U1 plus n minus 1 d. Un value is 100 equal U1 is the first term, which equals to 1, plus n, you want to find it, and d is a common difference. You can find it by subtracting any term minus the previous term. So 4 minus 1 equals 3. You can solve it by any way. I'm gonna move the one to the other side and subtract it. So 99 equal n minus 1 by 3. Now I'm gonna divide by 3 both sides. So n minus 1 equal 33. Move the negative 1 to the other side. So n equal 33 plus 1, 34. So you have 34 terms in this sequence. Now we're going to talk about the sum of the nth term of arithmetic sequence. The legendary example finds the sum of number from 1 to 100. So if you want to add the numbers from 1 to 100 quickly, how we do it? Let's list the numbers, the first few numbers, 1, 2, 3, 4, as you can see, and the last 4 numbers, 100, 99, 98, 97. If you add the first one with the last one, you're going to get 100 plus 1 equal 101. The same if you add the second number and the one before the last number, so 99 plus 2 equals 101. The third number and the one before, still 101, and so on. So if you add each two numbers, you're still gonna get 101. So you have 100 number. Each, the sum of each two is 101. So this is n. So Sn equals n equal 100. So S100 equals 100 number over 2 equals the sum of the first number plus the last number, which is 101. And you calculate it to find the sum. So equals 50 by 101 equals 5050. This is how the rule of the sum come from. You have two rules, as you can see it in the data booklet. Okay, the formal booklet rule. The two we wrote down. The first one is Sn equal n over 2. U1 is the first term, and Un is the last term. And you may use it in the exam if you have the first term and last term. The second one is actually the same of the first one, but we replaced Un with U1 plus n minus 1 d. So U1 plus U1 equal to U1 plus n minus 1 d. And we use it if you have the first term and the common difference. Okay, you may use anyone in the exam, but actually if you used the one depends on the given you have, you're gonna save more time. In this example, you have arithmetic sequence have first term 5 and the common difference -2. And you ask it to find the sum of the first nth term. You have the formula booklet and you have the two rules, but which one are you gonna use it to save time? So I have the first term and the common difference. So this one is better. Sn is 10 because you want to find the sum of the first 10 terms. N is 10 over 2. 2u1, 2 by 5 plus n minus 1, 9 by the common difference D negative 2. And calculate equal 5 by 2 by 5, 10, plus negative 18 equals negative 8. 5 by negative 8 equals negative 40. In this example, arithmetic sequence has first term 10 and last term 1000, and you want the sum of the first 30 terms. So this time, the second rule is better because you have the first term and the last term. Sn is 30 equals 30 over 2 by the first term 10 plus the last term 1000. So S30 equals 15 by 1010 equals 15,150. The next part, we have the mysterious sigma notation. Sigma notation is just another way to write the sum of the sequence. So instead of writing u1 plus u2 plus u3 plus etc., and you want to find the sum of this sequence, you may find it in the sigma notation and write it by it. So we start with un, the general rule of the sequence. N equal 1, the term 1 is the number you're going to start from, and n is the number you're going to stop at. You may also find the sum from the third number. So this time I'm going to write the sigma notation with n equal 3 to n un. That means you want the sum from the third number to the end. So u3 plus u4 plus u5, etc., to the last one, un. In this example, you have arithmetic sequence with first term 5 and the common difference 2. Find the sum of the first 22 terms using the sigma notation. The sigma notation, to use it, we need the general term. You need the starting point, which is 1, and the ending point 22, because he said find the sum of the first 22 terms. So starting from u1 to u22. So now we have just to find the un. We can find un easily by substituting in the general rule. Un equals u1 plus n minus 1 d. u1 equals 5. You don't know n, so n minus 1, d is 2. Expand and simplify, so 5 minus 2, 3 minus 2n. This is the un. So all you have to do now is replacing un with 3 minus 2n. And we solve it by GDC. I'm using the TI. And select the sum, writing the variables n equals 1, 3 minus 2n, 222. Enter. So negative 440. If you use the TI-84, this is also how you do it. Math, go down to 0, or just click on 0. Fill the blanks, x from 1 to 22, 3 minus 2x, and click enter. So negative 440. In example 7, you want to evaluate the sigma notation using the GDC. So we're gonna do it the TI-Nspire first. As the last example, you may go up and press enter to copy the previous line and just edit it. So 5r plus 2, and from r equals 3 to 10, 276. By the same way, you can use the TI-84, go up, press enter to copy the last line, write 5x plus 2, and to 10, go back to x equal 3, 276. In example 8, you have the sum of the first n terms of the sequence is 465. So Sn equal 465. And from the sequence you have the first term u1 equal 3 and u2 7, so d equals 7 minus 3 equals 4. You want to find how many terms I have to add in this sequence to get the sum equal 465. So Sn equal, we're going to use n over 2, 2u1 plus n minus 1d, because you have the common difference and the first term. Substitute Sn equal 465 equals n over 2, we don't know it, 2u1 2 by 3 6 plus n minus 1 by the common difference 4. Since we have the GDC, so we're just gonna solve it by GDC from here. Using the Nspire first, you may create a new page or continue on this page. You can create new page by Control I, calculator 1, then menu, algebra, and select nsolve. So menu 3, 6, and write the equation you have. 465 equals n over 2 bracket 6 plus another bracket n minus 1. Okay, here is the tricky part. You have to write multiply on GDC to evaluate it correctly. Okay, and outside the bracket, solve comma, solve for n. Click enter. You should have the answer is 15. To solve this example using the TI-84, you're gonna click on math, go down to the end or up one time, numerical solve, and click enter. You're gonna enter the left hand side 465 in E1 and the right hand side n over 2 in E2. After you finish, click OK, which is graph F5. Now, as you can see, he said select variable plus solve. So x equal, if I write any number, for example, -4, he's gonna give me an answer, the closest answer to -4. Okay, this is -4, and alpha, enter for solve. So he gave me -15.49999. But as we know, there is no n negative, and it should be positive. So you should guess a positive number. For example, I'm gonna enter 7 and I click solve again. So he gave me a positive answer, which is 15. Okay, so this equation is quadratic because you have n outside and the n inside. So at the end you have n power 2. So you have two solutions, one positive, one negative. The easiest way to answer using the TI-84 is to graph it. Go to graph and enter y1 and left hand side and y2 as right hand side, and I click on graph. There is two intersection points, one in the positive, one in the negative. So of course the solution of this question is positive. So you want to find the intersection, the positive intersection. Click on second, calculate, and find the intersection 5. Select the first graph and click enter, second graph and click enter. Also it tell you guess where is the intersection you want. You want the right intersection. So if you guessed, stopped here and clicked enter, he's gonna give you the answer -15.5. Okay, so you have to try again. Second, calculate and intersection, click the two curves and go to the right side. Okay, so if I stopped anywhere here and click enter, they're gonna give me the positive answer. This way is easier and show you already how many solutions do you have. Okay, so at the end, n equal 15. Thank you and good luck.